Okay, welcome back, grade 9 students. We're on to our second week of online learning. And this week we're done with chapter 5. We're heading into chapter 6. So we're going to start learning all about linear equations. So what's a linear equation? Well, earlier in the semester, we did a lot of stuff about exponents. When we learned about exponents and powers, that's something that should be helping you to make sense of the way that the COVID growth curve goes. The COVID growth curve is something that's exponential. That means each day that goes by, it's going up by an exponential amount. So if there were 2 cases the first day, then there could be 2 squared the next day, 2 cubed the next day. And it makes that growth curve where it starts out really slow and then it gets really steep really fast. With linear equations and linear growth, it's a type of growth. So if you looked at the graph, you'd see a straight line going from left to right. So it's going to go upwards from left to right, or downwards, or straight across. Those are all examples of linear relations. So we're going to do a whole bunch of stuff about that. Before we can get into that, though, we have to start looking at working with equations. Okay, so we've done some of this in class, and we're going to look at some of it in more detail today. So first, we're going to start with the idea of inverse operations. And inverse operations, that's the idea of the opposite of something. So when we talk about adding, the opposite of adding would be subtracting. We talk about multiplying, the opposite of multiplying would be dividing. Talk about squaring something, the opposite of that would be taking the square root of something. So what we want to show here, just one sec, I gotta change to my pointer. There we go. Let's look at this, for example, okay? So if we have, here's our equation we're starting with. X multiplied by 3 gives us 3x, okay? So x times 3 is 3x. So how would we undo that? If we wanted to get back to x, what would we do to this part in order to get back over here? Would we add 3 to it? Would we subtract 3? Or would we divide by 3? So we have to know what's the opposite of multiply? That's divide. So we're going to do the opposite. We're going to divide by 3 to get back to where we started. So that would be the answer. I don't know why it's not showing. That's okay. Okay, so let's look at what that means here. Okay, so when we talk about solving an equation, what we're really talking, you'll hear words like isolate the variable, put it all by itself. We're socially isolating right now. We're staying all alone by ourselves. So when we talk about a variable, remember the variable is this quantity that can change, and it's represented by a letter. A lot of times it's x. Oops, I didn't mean to do that. But sometimes it's a different letter. It can be a different variable. In this case, we're going to do x. So here we have x plus 2.4 equals 6.5. Okay, so what does that mean? It means we took x, we don't know what that is, we added 2.4, and then we end up with 6.5. What did I miss with? Start with x, okay, identify the operation applied to x to produce x plus 2.4. So we said x plus 2.4 gives us what we started with, x plus 2.4. So what is x plus 2.4 equal to? Look, it's equal to 6.5. So watch what's going to pop into this box over here. Okay, there it is, the 6.5. We can see it over there. Since x plus 2.4 is equal to 6.5, if we want to go back to the start to figure out, well, what is x? We don't know what it was. It was something that we added to 2.4, and we ended up with 6.5. So to find out what it is, we're going to say 6.5 subtract 2.4. So the opposite of add is subtract. Subtract 2.4, and that's going to give us 4.1. Okay, let's look at an example. For each statement below, right, then solve an equation to determine each number. Verify the solution. So that means check to make sure your answer was right. Okay, so look at A. It says 3 times a number is negative 3.6. So 3 times something is equal to negative 3.6. So if we were going to write that out, well, that's a lot all at once. N could be our variable. Just one sec. Okay, so if we said a number is n, so that's the number, 3 times a number, 3 times n is equal to minus 3.6. So there's our equation. If we wanted to build using these boxes, we'd say we start with n, multiplied by 3, we got 3n. 3n is the same thing as minus 3.6. That's what equals means. This side's equal to that side. These are equivalent, okay? So if we wanted to undo it, we'd do, instead of times 3.6, we're going to, or times 3, we're going to do divided by 3. So this divided by 3 equals, and then we could find out, do it in the calculator, whatever, and equals negative 1.2. So to find out if you did it right, we take the negative 1.2, we put it back into that n right there, back into that equation. The way we say that is we substitute the value back in for n. So 3 times negative 1.2, we check that and say, what do we get for that? And if our answer is minus 3.6, then we know that we did it right. Okay. So the second question, let me just cover this up a little bit. It says, let m represent the number. So let's look back and see what it was again. So the second question was, a number divided by 4 is 1.5. So something divided by 4 equals 1.5. Something divided by 4 equals 1.5. Okay, so here they said, oh, we're going to call that something m, whatever. Okay, you could say z, you could say p. Something divided by 4 is 1.5. So there we go. So if we want to write that out in our boxes, we start with m. What do we do with it? We divide it by 4. So now we have m divided by 4. And what's m divided by 4 equal to? It's equal to 1.5. So on this side, we could put our 1.5 in. Those are the same. So to get back and figure out m, we're going to do the opposite of what we did up here. So here we did a divide. So now we're going to do a times. So 1.5 times 4 equals 6. So now if we wanted to check that to see if it was right, we would go back up here and we'd say, okay, and if I think m's equal to 6. So what's 6 divided by 4? Is it 1.5? Yes, then you got the right answer. If it's not 1.5, then you did something wrong. Okay, that's what they mean when they say verify the solution. Why is my cover gone? Just a sec. All right, so I had to pause a couple times to tell my kids to be quiet. Sorry about that. Okay, so now we're in example 2, solving a 2-step equation. So this is going to be a little bit more, but it's still the same idea. We're using opposite things to undo what we already did. So look at A. Look at this equation. 4.5d minus 3.2 equals negative 18.5. Okay, so what's that mean? I have 4.5 times d, and then I subtract 3.2 in order to get over here. So what am I going to do to solve for d? Okay, so let's look at building the equation. See how there's 2 steps now? I start with d. What did I do to it first? Well, first, I times it by 4.5. So then I got to 4.5d. Then what did I do? I had 4.5d. I subtracted 3.2. So subtract 3.2 to get what I can see right here, right? 4.5d minus 3.2. That's how I got there. So in order to get back and find out what d is equal to, okay, well, I know that all that is equal to minus 18.5. So we're going to fill that in down here. Then we're going to do the opposite of takeaway is going to be plus. And then the opposite of times is going to be divide. So let's look and see what that looks like. So we start with minus 18.5, okay, that. Do the opposite of this, plus 3.2. Then we do the opposite of that, divide it by 4.5, and we get this number, negative 3.4. So if we want to find out if that's right, see down here, it starts talking about to verify the solution, substitute d equals minus 3.4 into that equation. Okay, so that means we're going to take the answer we got, minus 3.4. We're going to stick it into the equation right there as d. Okay, so it's going to be 4.5 times negative 3.4, take away 3.2, and we're going to find the answer. Just ignore this part for a minute. We're We're going to find the answer to that whole left side. If it's the same as this, then you know you did it right. If it's not, then you made a mistake. Okay, so let's look. 4.5 times minus 3.4, that's minus 15.3. Take away 3.2, take away 3.2, equals minus 18.5. That's the same as what we see here. Hooray. Huzzah, you did it right. Okay, perfect. Let's look at the second one. So we're getting the second question is going to be this one. R divided by 4 plus 3 equals 7.2. So let's see how we do it. Again, all my secrets are revealed immediately. Let's see. So what did we do? We took R, we divided it by 4. Whoop, to get R over 4. Then we did plus 3 to get the whole thing we started with. R divided by 4 plus 3 divided by 4 plus 3, right? So to get back to the other side, we're going to say, okay, well, we know that all that's equal to 7.2. So under this box, it will be the 7.2. Then we're going to do the opposite of that. So plus 3 turns into minus 3. Divided by 4 turns into multiplied by 4. Let's see what happens. Amazing. Okay, so minus 3 times 4. Okay, so we're going to do that, get our answer. There it is, 16.8. 16.8. Okay, so once we get our answer, 16.8, we have to verify it, check and see if it's right. So again, that means we take the 16.8, put it in for that R, and then do all this stuff. See if it's equal to 7.2, okay? So 16.8 divided by 4 instead of R divided by 4. Okay, so we're taking that, we're putting it right there for that R. 16.8 divided by 4, 4.2, plus 3, 7.2, 7.2. Yay! Okay, you're right. Good, we're done. Now you can go do your practice for this week. Good luck. Ask me questions, send me questions in the chat or by email if you need help.